Okay, this is the video for CPE 301, Midterm 2, the final assignment of this class. It's been a long time coming. Right, so let's do the usual thing here. I'm going to basically walk through some code, look at the final result of some stuff, which in my opinion, was not fantastic, but it did output as it should, and then we'll show you some results in the serial port in this situation. So, okay, so this midterm is basically based on the same concept as before to be able to do I2C communication. In this case, we're actually using the AP. I always forget the name. AP, this little guy, the APDS 9960. This is a breakout board, in this case produced by Adafruit, which utilizes the APDS 9960 sensor, which is basically just like a light, varying light types and gesture sensor that can be used with a variety of microcontrollers. So, basically, we're pulling data from it, pulling the light that we're seeing from it, and we're able to push it in. So, using that in conjunction to the MPU. So let's talk about that real quick. So, like last time, the important thing was being able to put together a file or put together a header file that recognized, well, two things, that performed our setup for us as well as allocated all of the register locations. So those register locations, which are actual physical locations within the memory of the device, are first off here. This is like the setup stuff, our enable, some of our enable, all the different timing stuff and configurations, and then the different color types which we can pull from the device itself. So white or clear light, red, green, blue. Datas. In this case, they're pairs, high and lows, like last time, like in the MPU. And then here's a couple of other setup items. This is stuff that's been recommended. This code was actually developed basically in conjecture to an Arduino code that already had a header file that was similar to this setup, and then we were able to work it to the way we needed to work completely in C later on as we developed some code. So this is some stuff we worked on with a couple of groups in the class that was able to put this together. So definitely a group effort for that. Okay, so yeah, there's a bunch of, again, relating to the register locations, and that's kind of the important thing, is like these register locations are holding the values after we perform some of our setup code relative to the actual device itself. See? And then we're going to use UART, one, to be able to display it so we can just see it as it's kind of pulling values in real time. And then two, we're going to use the ESP device. This ESP device is pretty finicky, especially like when we try to like work in connection to doing the ThinkSpeak website, because one, the ESP module we've had trouble with before, being able to make sure we could write to it, getting the firmware that's needed to run and operate correctly on the AT commands, and then being able to write to ThinkSpeak can actually be really slow. Their minimum allocated time that free account users are able to upload stuff is about 15 seconds. Well, that being said, like, even though I'm actually sending on an average of every 15 seconds, that doesn't mean it always ends up being loaded into the website correctly and stuff too. So again, these commands are the same. AT commands here, incrementing through time and stuff like that. I made a convenience. I just wrote some of these, showed them inside here, and then did stuff below. And then I just basically was iterating through those same statements again and again for each color. So I was doing it one by one because I was actually having trouble getting it to accept all four values at the same time. So red, green, blue, white, clear, either way you want to call it. So this is here's that initialization code we pointed out. This is I2C code right here. And let me talk about that now. So this is the code that was given to us before, relatively, to help us to write and read through I2C communication. So in this case, our setup's already been done. In this case, I'm just pulling values over time from these registers. In this case, white, red, green, blue. If you notice here, for some reason my C code in Atmel would not recognize the header or the definition I made, so I had to just push the register location directly in here. So you can see that I wrote these up here though. Right here. Yeah, 94, 95. I threw these in here, and Atmel, which is finicky sometimes, would not pull these in. So anyway, that's why you see those are not the actual just header, nice little naming conventions, the low and high. But the important thing is that we're reading the low and high registers for each color and then pushing them inside the variable we defined here, white, red, green, blue, and then we can do what we want with it. We actually then we would take that data here and write it, or I should say serial write it using AT commands to that. So, all right, real quick, since we've walked through that, let's go ahead and look at the output on the visualizer. And to be expected, right? So basically, we're just iterating over and over and over, sending those over a period of time. I've kind of separated through time. Got field 1, field 2, field 3, field 4, which is 0 this time, and we're just running back and forth in between each of these. So these are some earlier values. In this case, I had my kind of buried as I'm kind of just passing by, depending on the moment, the instant, because it's really short. But at some point, well, let's actually just do that now. I'll show you. Let's go over here, open this up. Okay, very good. So this is my kind of the final plot of data as it's coming through. In this case, this is the point I was going to make here. It's like, yeah, I'm seeing values but getting printed in the serial monitor and stuff like that, but it's kind of patchy with respect to like how soon those end up getting shoved into ThinkSpeak here. As you can see, the red, which is typically the first one, always ends up doing well. The green, which is second, doesn't always catch. This third one, yeah, it catches again, kind of patchy. And then this last one, the white one, is hard. I really have a hard time getting it to work at all. Like I actually was like just turn it on and iterated white over and over and over again to the field, and it would hardly push values. But indeed, it did catch one, showing that it does end up pushing through. So it's strange why this was kind of running, why this is running funny. So anyway, that's it. Oh, let me show you the board over here. Let's look at this. So again, there's the board. I used a PB, so I actually had to change code with respect to setting up I2C, because it actually has two I2C configuration registers related to that. There's our ESP module, like as before, little ugly finicky guy, and then as before, there's the APDS module, all wired up nice and pretty. So, well, that's it. That's the end of the semester. That's the full video, and we'll hope you enjoyed the semester. Thanks.